Yes, sir.
Good morning to the construction professionals and the panelists who have joined us. Dr. Prasanna, who is the chairperson of RAGI 2020, and Engineer Prakash, who has also joined us, and all the construction professionals who have logged in to listen to the speaker of the day today, Professor Dr. G.R. DODAGOUDAR, who will be talking to us on materials, the environment, and pile raft foundation. This is the fourth and final talk as part of the National Workshop on Recent Advances in Geotechnics for Infrastructure, RAGI 2020, which is being jointly organized by Association of Consulting Civil Engineers India, Mysore Center, the Ramcos Cements Limited, Indian Geotechnical Society, Bengaluru Chapter, the National Institute of Engineering, Mysuru, and Sri J. Chamarajendra College of Engineering, Mysuru. As far as today's speaker is concerned, he is professor at Indian Institute of Technology, Madras, IIT Madras, since 2002. He obtained his diploma in civil engineering in 1988, bachelor's degree in civil engineering from Basaveshwara College of Engineering, Bagalkot in 1992, master's degree in geotechnical engineering from IIT Bombay in 1995, and doctoral degree also from IIT Bombay with specialization in geotechnical engineering. Professor DODAGOUDAR has 1 year experience in industry and 18 years of experience in research and teaching. He has guided 14 PhD students, 7 MS students, and 20 MTech students so far, and presently guiding 9 PhD students and 1 MS student. He has published 59 papers in international journals and 42 papers in national journals, and has presented more than 120 papers in proceedings of conferences. He has written 1 book and 2 monographs. He is very active in continuing education programs and delivers lectures and motivating talks to students, academicians, and working professionals across the country. So we welcome today's speaker, Professor Dr. DODAGOUDAR.
Thank you, sir.
To this event. And before I hand over the proceeding to DODAGOUDAR, let me also say that we at Ramcos are privileged to being associated with the various professional bodies who have made it possible to bring in speakers of repute in the field of geotechnical engineering. As all of us know, the first 3 lectures, which was delivered by Professor Madhav, then we had Engineer Mohan Prasad, and yesterday we had a talk by Engineer Aniruddhanji of, he is also a consultant from Chennai. So we had the 3 interesting talks on various aspects of geotechnical engineering, and it has helped us to narrow the bridge between theory and practice, because as all of you would note that most of the discussion was based on based on well-documented case studies. And I'm sure that many of us would have been able to connect ourselves with as to how important is geotechnical engineering, because until unless the foundation is not strong, the building cannot be stable. So we need to concentrate on that. We all, during our interaction with construction professionals, we have seen that most of us give importance to concreting, to design, to various practices at site. But how many of us give importance to the study of soil, to the study of foundation engineering is what we need to understand and we need to appreciate, because that is where the foundation of civil engineering rests. So with those few words, let me welcome Professor DODAGOUDAR. You can start your presentation, sir.
Thank you, sir. Please share the.
Yeah, it is. You can click on the share content, and you can upload your presentation there.
It's okay.
Yeah, it's okay.
Okay.
Screen, please.
Your video can be. Your video is in mute, I believe, sir. We are not able to see you.
Yes. Okay. Now you please see.
Now we are able to see you. Welcome, sir.
Yes. Thank you so much for your wonderful introduction. Shall I start now?
Please, sir. You can.
Am I audible
All
now?
yours. Yeah, please.
Good morning to all. My name is DODAGOUDAR. I am from IIT Madras. My topic is materials, the environment, and file draft foundations. Someone must be wondered why these combinations. Anyway, in order to construct file drafts, you have to use materials. Invariably, all our foundations have to be in the environment. In that sense, I have chosen this topic. Now I am going to briefly explain what are these materials, how much one should need to know about the materials. The moment you do any activity in the environment, what will happen to the environment with regard to the construction of file draft foundation? Let's start with the first slide. Okay. Now you may be thinking which is most important in these three things, whether materials are important, whether the environment is more important, or file draft foundations are more important. Depending on the important, one can think about this important statement. The most important thing is to keep the most important thing the most important. I don't know who has given this statement, but it is well fitting to the present topic. Okay. Now I want to tell a little bit about the big picture. This is the big picture. I hope most of you people may be knowing about finite element. The use of finite element is to predict the behavior of a prototype well in advance before erection. You can achieve this through computational modeling, or else you can perform physical modeling in 1G scale, or else you can use the centrifuge modeling, that is NG scale. Invariably, finite element requires the constitutive models. The parameters needed for the constitutive models have to be evaluated based on the element test, or at the most you have to perform field test in order to obtain the parameters. Later you can use any of the softwares. Nowadays softwares are so powerful, you can rely on those results and then you can execute the constructions. Now coming to the big picture about the file draft foundation, this is the picture. Here I have shown you how to perform the soil structure interaction analysis using one of the methods that is called substructure method. Nowadays softwares are so powerful, you can attempt in a single go complete soil structure interaction analysis. Otherwise you have to divide, especially for the first two part you can use one software. Take for example, in order to evaluate the foundation input motion, it may be subjected to translation or it may be rotational motions. Then you have to evaluate the impedance function, and then you have to combine the structure. This part, the last part, can be carried out separately using some other software. These two, that's the reason it is called as a substructure method. Presently one can carry out all in a single software. Similarly, one can think of what could be the big picture about file draft foundation. As far as static analysis is concerned, the big picture about file draft is nothing but this figure. Especially load settlement curve itself is the big picture about the file draft foundation. You may be surprised why I am telling like this. The moment you bring in the dynamic soil structure interaction, you have to think totally different. That too, the big picture is the number 3 curve. You please see this very carefully. If you are able to produce this curve based on experiment or based on finite element simulation, it is the end of it. Depending on the allowable settlement limit, you can decide the design load. And then one has to be very careful about this kink. Okay. At this level, your pile as well as the raft is in fully elastic. In case you want to make use of your piles little more, then you can think of shifting towards this point. Usually this point is 1/10 of this total line. Please understand. I am audible now?
Yes, sir.
Everything is fine now?
Yeah, it's fine.
Okay, fine. You please understand this part very carefully. Before jumping into the materials and environment and then analysis and design or soil structure interaction, please try to understand this curve. This curve is very, very important as far as static analysis of file draft foundation is concerned. If you are not sure how to bring in the more effectiveness of your pile, you have to stay at this point. Invariably, whatever settlement you are going to get here is the allowable settlement. You can have the design load. In order to utilize your piles to full extent, usually you are going to design for full capacity of the piles. In the case of pile draft foundation, this will be this particular point or this distance will be 20% of this line, or else it will be 1/10 of this entire line. Okay, this we will see later. And then now we are all under COVID lockdown. Especially this statement is for everyone. If you are the world to someone, please listen this very carefully. So take good care of yourself. This is very, very important. Don't wait for the government to come and take care of yourself. With this, I'll move on. Please this see very carefully, especially for the students. Whenever, let's assume I want to keep in this location, how to study with the mind maps. Let's assume I want to keep this file draft foundations. I want to become #1 in file draft analysis and design. Okay, most of the times in life, everything starts with how can I master the art of design of file draft foundation. First of all, you have to have the background and historical notes. That is very, very important. Even you want to tell a legacy of yourself, you need to know your father, grandfather, great grandfather. Then only that legacy will be carried forward. Similarly, in order to master any topic, let's assume I'm going to keep a particular topic here. Take, for example, reservoir construction. Okay, what is the idea or concept behind? That is very, very important. Without idea or concept, you cannot do anything. Even to run a life, you're supposed to have idea or concept. Once you have, and then what is the principle behind? Anything, wherever you see the load, wherever load is there, whether you are going to put load on any steel or any structure or anything, you have to have the principle. Once you have a principle based on some fundamental assumption and basic formulas, one can develop the theory. Theory means most of the times these are equations, especially when you are using finite element. The theory means differential equations. Most of the times you are going to get only partial differential equations. After all, what is this differential equation? Differential equation is equal to continuity equation plus constitutive relation. Especially with respect to file draft foundation, this constitutive relation is stress strain relations. When you have a theory, anyway you're going to get a solution, but that solution has to be verified through experimentation. That is called validation. Why are you doing all these things? When I told about reservoir, after all, you are doing this for society. When you are doing something for society, one has to practice with ethics. When you are not expert, you please take the help of someone. Otherwise, don't jump in. In that sense, I have given this particular slide. Now, this is what my outline of presentation. Am I audible, please? Hello?
You're audible, sir.
Yes, please. Now, please concentrate on this outline. First, I will talk about sustainable development. Nowadays, this sustainability has been overused, mostly overused, without knowing much about sustainability. When you talk about sustainability, after all, you are going to use materials and environment. Later, in between human beings or non, some human beings will going to come. When you talk about materials, we need to know a little bit. It is not just, I want to know, construct only foundation. It is not enough. Foundation means there are many things. Take, for example, you are using concrete for construction of foundation. If you don't have cement at the site, you don't have aggregate at the site, you have to think how the cement is going to come. When you are transporting, you are going to add or you are going to consume a lot of energy. Okay, in that sense, these are called as a life cycle phases: production, manufacture, transportation, and use. Then we'll move on to the D foundation. File draft foundation is one of the D foundations. What are the design principles? As usual, we have a design principle for other foundations. Here also we have. But one of the important components of file draft system is the construction itself. No matter how complicated analysis technique or software or your data, if you are not constructing, during construction, one has to monitor the progress. When you are monitoring the progress, let's assume you have constructed 100-story. 100-story you have constructed means literally you will be knowing how much weight you have put on the soil. Based on that, you have to evaluate the total settlements. That is coming from the actual monitoring. Using finite element, you will be knowing how much weight you are putting at the 100-story. Then you have to compare. For that reason, construction and monitoring is very, very important. I'm not going to cover much on that. Then analysis and design is very, very important. And then some environmental considerations. Why, when you are designing foundations, how much importance one has to give for materials and the environment, followed by summary and few remarks. With respect to sustainable development, let's see this statement. Actually, this was given by Albert Einstein so many years back. We shall require a substantially new manner of thinking if mankind is to survive. The seeds of sustainable development have been showed at that time. It is our duty to understand the meaning between the words. With this, we'll move on to the definition of sustainable development. These are simple definitions. In this case, we are thinking about global well-being with the proper use of all economic and natural resources, and then respecting the people and other living beings. This is what is the more comprehensive definition. This is a concept describing mankind's ability to create a world for humans and non-humans that environmentally, socially, and economically. Please this word carefully. First of all, you have to have environmental word first. You are not supposed to bring economy first. Even if you are not having any economy in your design, perfectly all right. Environmentally, socially, and economically provides for a current population needs without damaging the ability of future generation to take care of themselves. If at all you want to put it bluntly, sustainability means you should enjoy enough. You can allow others to enjoy. At the end of the day, you should see that you have to keep enough for the future generation to take care of themselves. That is what is your sustainability. It can be put it in this form: sustainable development and habitat. What are you calling as a sustainable development? Anyway, this is a sustainable. Anything which is sustainable, it has to be bearable, equitable, as well as viable. Now, just see this particular figure: renewable construction. This has come from Indian villages. Okay, most of the construction in Indian villages are all sustainable. Okay, when you talk about this New York, this is the construction taken from the part of the New York. It is not at all renewable. Okay, it is a non-renewable construction. One should avoid. This is about the sustainable development. With this, we'll move on to the materials. What are materials? When stuff is useful, we show it respect and call it a material. When the same stuff ceases to be useful, and then in that case, we will not respect, then we will call it as a waste. Basically, definition of material and waste is relative and it differs from person to person. Then where do materials come from? Most of the materials have to come from crust only. But we have 92 usable elements. Most of them are metals. See this particular figure. These top 8 elements, basically these 8 elements will going to constitute 98.5% of the total elements available in the world. All these elements have come from the earth crust. One is expressed in terms of ppm, another one is percent weight. Now, what little more about the materials. Then why materials are so special, and then with respect to human being, why you are so special when you are using materials. Homo sapiens, that means us, differ from the other species in its competence in making things out of materials. Please, you have to accept this competence. We are not alone in the ability to make. Like us, there are many creatures in the world, they are going to make some things out of the material. But the difference lies in the competence demonstrated by man in his extraordinary ability to expand and adopt that competence by research and development. That is the reason we are having edge. One can say materials, literally what they have done, materials have literally advanced the mankind since earliest beginning. You can just see even our civilizations have been named after the materials. Okay. Another important point here is one has to understand a little bit about the embodied energy. Okay, I will tell you in the next slide what is this embodied energy. Take for example some materials. Steel is 26 megajoules per kg. This is the annual consumption. Right now, this is 10 years back, this was annual consumption. Similarly, we have aluminum alloys, polyethylene, concrete, device grade. See, take for example concrete. Even though the embodied energy is 1.2, but the cement industries are not that effective or not that efficient. Right now, the concrete consumption annually is 30 billion tons. You please understand, it is a 30 billion tons. It is not just 1.5, it is a 30 billion tons. Now, this particular slide shows the concept of embodied energy. Take for example, I want to produce the PET pellets, polyethylene terephthalate polymers. You need to have all these. We have to have oil derivatives, and then you have to have the energy, that is the total plant energy, and then you have to transport material from the site to the where you have the production plant. While so doing, no doubt you will going to produce the product, that is the PET pellets, and then you will going to have some emissions like CO, CO2 and NOx and then SOx. These PET granules, finally what will happen, you will going to come with the embodied energy per kg per pellet. What is this embodied energy? The energy per kg of usable material is the embodied energy of the material. Even though you are constructing file raft foundations, how much cement you are using, how many aggregates you are using, how much literally you are excavating, all one has to, because everything depends. I want to tell you at this point, 21st century living is equal to material consumption plus energy consumption. Nothing more than this. I want to tell once again, 21st century living is equal to material consumption plus energy consumption. Somehow you have to consume these two sparingly. Okay, where this PET is used, literally talk about materials. These are all different materials. Actually, PET granules are used in the manufacture of these containers, especially these cold drink containers, what you are seeing here. Now, evolution of engineering materials with time. How these materials have evolved since from civilizations. To talk about Stone Age is a relative importance. Okay, talk about Stone Age. In between you have a Copper Age, Bronze Age, like that you have a age of molecular. Then start from 10,000 BC. Now you see what will happen here, percentage, ceramics, glasses, composites, polymers and elastomers and metals. Okay, a little more about materials. Materials probably the more deep seated in our culture than most of us realize. Materials are used extensively in transportation, housing, clothing, communication, recreation, and food production. Virtually every segment of our lives is influenced to one degree or other by the materials. Basically, what has happened historically, the development and advancement of societies have been intimately tied to the members' ability to produce and manipulate materials to fill their needs. Accordingly, our early civilizations named after the capacity of the human beings to develop the materials to fill their needs. Accordingly, they are called as Stone Age, Bronze Age that you have seen earlier. Then now coming to the material evolution, the time material evolution, you just see at the bottom, the timeline is very big. Just see at the top, the timeline is very, very small. Now we are at the molecular age. That is 2020 AD is a molecular age. One has to appreciate. Here there are some ADs are given. During that year, that material has come first to the world. Now coming to this dependence and dangers. Dependence is dangerous. If you depend on anything, take for example, nowadays for COVID treatment, we are depending on government. How many days one can depend on government? Who have to take care? Dependence is dangerous. Dependence explores you to exploitation. That is the biggest problem. That's the reason we are using non-renewable material up to 96% right now. You have to be very careful. Earlier, you used to treat materials are the faithful servants of human being. If at all you want to give something to the new generation, we as a human beings at present, we are supposed to be obedient servants of the material. Then only you can achieve the objective of sustainable development. With this, I'll move on to the materials and the environment. How this environment is connected with the material. In all human activity has some impact on the environment in which you live. The environment has some capacity to cope with this, that a certain level of impact can be absorbed without lasting damage. If at all you are creating some impact, if it is a small, yes, environment is going to take care of on its own. But it is clear that current human activities exceed this threshold with increasing frequency, diminishing the quality of the world in which we live and threatening the well-being of future generations. At least part of this impact derives from the manufacture, use, disposal of products, and products without exceptions are made from materials. That is how these materials and environment are related. What is the remedy for this? The remedy is you have to go for environmental design. In the environmental design, we have two designs. One is for the environment, another one is for the sustainability. What is the design for sustainability? When you talk about sustainability, you have to adapt to the lifestyle that meets present needs without compromising the needs of future generation. Time scale is measured in terms of decades and centuries. Even though you are designing file Raft, you have to think not in terms of 1 or 2 decades. At least you can think half a century. That is designed for sustainability. And then little bit about the material life cycle, just for telling others. You will maybe seeing only product, how the product has come. Usually it will going to come to the natural resources. That may be energy, that may be feedstock. Feedstock means your raw material and ore, and then the transport. Most of the times ore will be available elsewhere. That has to be transported to the some initial factory site where you are going to produce the materials. You have to have everything. When you produce anything, finally you are going to have some emissions. That emissions may be in this form. Later it will go to the factory. There you are going to produce the product, and then the product will be used. Maybe after the end of its first use can be discarded, or it can be recycled or downcycled. Finally, after completion of the complete life, it has to be disposed. Okay, this is how we are going to make use of this material life cycle. Then coming to the 21st century living. The 21st century living is little difficult because of the growing population. You just see this slide, 200 years only given. First 1500 years, the doubling is 750 years. After that, doubling is 330, 90. And right now it is a 45 years. We don't know where we are going to reach. We are more towards the 8 billion population now. And then this is the slide giving the population of the 25 most populous countries. Am I audible, please? Everything is fine so far? Hello?
It's fine. You can
go,
okay. Sir.
Yes,
if there is any problem, we will let you know, sir. There is
yes,
no
please,
point.
yes, please.
Thank you.
Thank you, sir. Okay. As I mentioned, 21st century living, please read this very carefully. If you adopt this particular slide in your daily life, or for that matter, any of our professional activity will be ultimate. Anyway, now time is not there, but I want to tell you a little bit about this. As I mentioned earlier, 21st century living is called to material consumption, energy consumption. Even in case of construction of file Raft foundation, we are going to do only these activities: material consumption and energy consumption. If at all you are miniaturizing, then you will going to have the beneficial effect. The green color is a beneficial or a positive influence, red is a negative influence. See basically what will happen. If you miniaturize without compromising any of the functionality, you are going to use less material as well as energy. Similarly, growing population, if you are creating a lot of wealth, your education will be increased. In that sense, one has to use this. Okay, little bit about energy consumption. You have a civil aircraft. Usually these are the life cycle phases. Material production. First one is the material production here. The second one is the manufacture. Third one is the transportation and use. Actually, in case of aircraft, while usage only, you are going to use maximum energy. Whereas in case of material stage or manufacturing, you are going to use less. Similarly, for the family car as well as for appliance like refrigerator. Whereas in case of multi-story parking lot or even any software park or any mall, you just see here in the material. In the usage, you may not use more power, But in case of private house, like our own houses, it is almost like a balance during material. That's the reason one has to be very, very careful. If you are using unnecessary some material which is going to consume a lot of energy, by that you will going to have a lot of losses in your building. That's the reason you have to invest a lot. Another one, fancy type of things, fibers, carpet, and all going to have a lot of material consumption in the beginning. So that then coming to the end of life options, there will be different end of life options. Anyway, I'm not going to spend too much time on this. And then in order to remedy all these, whatever so far I told about the impact on environment, one has to choose the eco design. Eco design consists of two. One is eco audit, another one is the design. It basically what will happen, these are the life phases: materials, manufacture, transport, use and disposal. Basically what you have to assess the energy as well as the CO2 release over life with respect to each of these five. Basically what you are optimizing here, you have to minimize. In case of material, you have to minimize these things: mass of part, embodied energy, and then CO2 per kg. Similarly, manufacture, transport, and use, and then especially in disposal, you have to select non-toxic materials and the recyclable material, and then accordingly you have to think of disposal. Then material charts for eco design. Let's assume you are going for eco design. This is not at all necessary in our geotechnical engineering or even structural engineering. Yes, to some extent they are doing. Nowadays they are thinking of using this waste material and then recycle aggregate and all. But one has to be very careful in order to extract the recycled aggregates, how much energy is literally utilized. These charts helps us to make eco-friendly material choice. That means eco-uniform material choice. One has to use this. Whether you want to use metals, polymers, or ceramics, or hybrids, accordingly you have to go. But only thing you have to ensure that your embodied energy is supposed to be minimum, whether it is unit per mass or unit per volume. And then if at all you want to select the best material for your beam with a specified stiffness and length, you have to think of selecting this. This helps us in order to make eco-uniform decision regarding the material selection. This is for the best material for the beam. Similarly, in case you are thinking about strength imputed designs, wherein you are aiming towards minimizing embodied energy, one has to make use of these things. All the materials are given over here. Even our concrete is also given over here. One can think, how are you going to make eco selection? I want to tell you regarding these materials. One is a glass, one is a PE, another is a PET, aluminum, steel. What are the design requirements? Design requirement is function, constant, objective, and free variable. First of all, I have to have a container for cold drinks. Then it's supposed to be a recyclable, and then you have to have minimized embodied energy per unit capacity. Let's assume per unit capacity is a liter. Then choice of material. Some calculation has been done with respect to these different materials over here. Then you have calculated the energy per liter. Finally, the best material is steel, 440 ml can. But you are using this for 1 liter. That is the reason you have to go for 2.4 megajoules per liter. Like that, you can think of any material. Similarly, you can adopt this concept for design of file draft foundation. I have given few example. One is the earlier one, and then crash barriers. For static barrier, how are you going to choose? M stands for material index. Depending on different type of application, this material index will be different. Then another one is a car bumper, or else you can think of even your dynamic or mobile barrier. How are you going to choose the material? Wherever you are going to have your least embodied energy, you have to go for it. Especially for this mobile barrier, you can think of using this thing, CFRP or light haulage and all. Okay, with this I'll move on a little bit to this one because it's the concrete Ramcos sponsored. Nowadays they talk a lot about sustainability, durability of concrete structures. That too with the byproducts and recycled materials. Because of a huge consumption of concrete, one has to think a lot, and then we have to face this challenge. Most of the times you will ask this question: is this a waste or is it a resource? This question is related to this particular slide. See, take for example, I have a pet coke, then I have a bagasse, rice, wood chips, or recycled aggregate. How are you going to use this one? Therefore, we have to develop approaches to implement advanced concrete and construction technologies in the construction of durable foundations, buildings, bridges, dams, tunnels, highways, roads, etc. in emerging economies. With this, I have covered the first part, materials and environment. With this, I'll move on to the pile draft foundations. Now see, basically I want to tell you, these are the major building parts. Anyway, everybody knows all these. In case you are going to have some cellar, in that case, you are going to call it as a substructure, otherwise it is a foundation. Both together constitute the foundation. Function of foundation, anyway, you know, we have to transfer the structure load safely into the ground. Usually two types of foundation, shallow. Raft is part of shallow. You have to understand the analysis and design of raft thoroughly before attempting to design a pile draft foundation. That's the reason I have given deep foundation. This is a raft foundation, and then this is just a configuration. How are you going to model the raft foundation? Over the years, we have started with subgrade reaction approach one can use in order to evaluate the interaction effects. And then if at all you want to bring in the coupling effects, one can choose the springs like this in order to evaluate the interaction effects. If you don't want to use that, you can use a finite element. You can divide the bottom of your raft into number of elements, and then these elements are connected spatially, and then this is connected in turn with the ground, the bed of springs like this. And then deep foundations include so many. Our file raft is a deep foundation. What is the specialty about deep foundations? Most of the times these are at deeper depths, usually more than 3 meters. They are also going to transmit the loading to deeper and more compacted strata. Okay, another specialty of deep foundations, these 2 points are really very, very important, even though they look trivial, in which the depth of foundation is very large in comparison to its width. This is very, very important. Once you understand and appreciate, you will understand how literally load is getting transferred in case of deep foundations. Another one, you cannot simply use open pit excavation methods to construct the deep foundations. For this, you have to have the specialized equipment. These are the 2 special features of deep foundations. This is a load transfer mechanism between deep foundation as well as shallow foundation. It's quite. What is file foundation? It's exactly same as your deep foundation. Is used to transfer loads to deeper and competent layer. These are the different types of piles. This is what is the usual file profile. And then piles are always used in group. They may be drill shafts or maybe piles, or sometimes now they are using wells. In order to construct a high-rise building, you don't have to think of using some small piles. Better you can go for single drilled shaft, or else you can go for a well. As far as India is concerned, you are using Kaizen, alternative name is well. Always they will be used in group. Okay, now see this carefully. One has to understand a little bit about the classification of file system. Even in case if you don't have time, at least you have to understand this. This is very, very important. Friction file and end bearing. Basically, in case of friction file, what will happen? End bearing resistance is derived mainly from skin friction. Reverse is happening in case of end bearing. Entire resistance will be borne by the base. Okay, these are the 3 important main design requirement as far as file foundation is concerned. Everybody knows this, but still I want to tell something about this. The most important geotechnical design requirement for most files is that they have sufficient axial load capacity to support the applied loads. I want to tell you one thing. If you design your foundation, especially using piles properly, and then your axial load capacity, 20% of that is capable of taking lateral load. Then pile transfer axial load through side friction and end bearing. Another important thing, you please understand and appreciate the last point. More displacement to mobilize store resistance than the side friction. That is depicted in this. This type of graphs have to be evaluated for the site specific requirement. Please understand this one. Please. Hello? Everything is fine?
Yes, sir. It's fine.
Yes. Okay. Please see this slide carefully. Nowadays, our IGS forum is also discussing a lot about this. Okay, a lot of material is available. Only thing, we will not invest more money to evaluate this graph from the field results. If you are able to evaluate from the field, you can literally solve all your problems. How much one has to consider the ultimate side friction. Just because soil is providing enough, one should not go for ultimate value of side friction. Okay, this is also very, very important. Before executing any of the file foundation activities, you have to respect all these points. But I want to explain a little bit about previous data or case studies and selection of file. Take, for example, I want to develop this particular area. Already these 2 areas have been developed. Based on this, I could be able to know what is the depth to bedrock. I should be able to get some idea about the soil properties. With this, what you have to do, you have to minimize the number of bolts for the new proposed development. Let's assume there are some areas you cannot use any equipment, you cannot go for cast in situ files. In that case, you have to depend only on the factory made or whatever available in the market. In that case, one has to be very, very careful while selecting the files. Okay. Now, a little bit about design. Usually, while design, we are going to look for allowable structural capacity as well as allowable geotechnical capacity. Most of the times, geotechnical capacity is controlled by settlement. In case you have negative friction, one has to cater for that. Okay, how are you going to get the pile capacity? In case you are going to use the separate factor of safety for shaft friction as well as end bearing, these are the numbers, typical one. Then how are you going to get the allowable? It is on single file. Summation of ultimate skin friction passing through different layers, then and then plus end bearing. This is all. In case you want to use only one global factor of safety, usually 2 is used in European countries. In India, we have to use 2.5. Only few companies, L&T and SPCL, they are using 2. One has to be very, very careful. If you have a total quality control during the execution, then only you have to go for 2. Otherwise, we have to go for 2.5. Then concept or idea of PRF. Why one has to go for PRF? Okay, now you please understand. Okay, please understand. Please see this very carefully. Let's see, this is a single file subjected to the load. This is the ultimate load. Let's assume this ultimate load I want to put in 4 parts. When you apply the first part, this is how you're going to get the stress or isobar. The second, third, and fourth. The moment you reach the fourth one, that means it's touched the ultimate. The same when you use for pile group, basically what will happen? This is the isobar of a single pile. This is the isobar of a pile group. Because of this isobar, you are going to have the highly stressed zone. Because of the highly stressed zone, you are going to have the high strain. High strain multiplied by the respective layer thickness.
The video is not visible, sir.
Hello, 1 minute, please. Hey, Sangeeta.
Yeah.
1 minute, please. Video is not visible. What you have done?
You can take a minute break also, sir. No issues.
It's okay.
Yeah, now you are not visible. The slide is visible. Now you are visible, sir. Yes.
It's perfectly all right now. Okay, anyway, you take a pass here because this is very, very important. We have to understand the concept of pile graph.
Correct.
I want to explain through this, and then another slide is there. Now see this carefully. In order to design pile group or even a pile graph foundation, one has to understand the interaction. Without understanding the interaction effect, otherwise you cannot do anything. Otherwise, what will happen if you don't know how to evaluate the interaction effect? Better you have to keep a large spacing so that you are not going to have any interaction. In that case, total load will be summation of the individual load capacities of a single file. Okay, but you have to evaluate. If you are not evaluating, what will happen? I want to tell you in the next slide. You please see the next slide. What will happen? I don't know. I don't want to evaluate the interaction effect. It is fine. It's left to you. Finally, you end up getting unnecessarily putting a lot of money below the ground. In this case, basically, what will happen? You are going to reduce the number of piles, no doubt. You will reduce the number of files, but what will happen to your thickness of pile cap? Actually, in pile foundation, pile cap is not going to transfer any load direct to this file. It is just acting as intermediate medium, taking load from the structural column. It is going to pass on to the piles. The moment you put piles far apart, what will happen? Requirement of your pile cap thickness will be tremendous. If you simply put a larger pile cap, it is of no use. Here, that the genesis of pile cap concept has taken birth. Okay, basically what? Anyway, I'm going to increase the thickness of pile cap. I am going to force the pile cap to transfer certain amount of structural load to the soil directly beneath. Then how are you going to evaluate how much load has to be transferred to the raft cap? In that case, cap will be called as a raft. Okay. Now you see basically what will happen. Some background and historical note. See, this first sentence is very, very important. Recent years have seen major advances in understanding of how file foundations interact with soil. Basically, you just see the number of papers published in file foundations are the highest. Nowadays, second highest are coming in ground improvement. Earlier, number of papers published only in the stability of slope and shear strength. In order to understand the shear strength phenomena, most of the papers published on stability of slopes. In now, what has happened? Now, see, particularly with respect to the group, the effectiveness of a pile in a particular group is generally reduced by the proximity of other piles. It quite happens even in human being. If you don't like someone who is sitting beside you, sometimes you will be not happy. Recognition of this fact. Basically, what has happened? Yes, I know. If I am putting n number of piles, the effectiveness of a particular file will be reduced because of the presence of other piles nearby. One has to recognize this fact. And then nowadays, current trends are more towards the use of less, more widely spaced files. This is the current trend. Okay, because of this, you are increasing the thickness of pile cap and you are forcing the pile cap to transfer certain amount of load. While so doing, you are allowing the raft to transfer or contribute to load transfer significantly to the soil. That's what is the concept behind. Now coming to the historical note, why people have gone for. Already raft foundation is perfectly understood, pile foundation is perfectly understood. Let's see one construction took place in Frankfurt in Germany. The construction time is this one. It is a Marriott hotel. Height is 162 meter. Constructed on raft foundation. See the total settlement. Maximum settlement of 34 centimeter. If the structure is not capable of accommodating this settlement, some problem will going to happen to your structure. That another one, this is a structure constructed again on the raft foundation. Height is 155 meter. See here, minimum is 10 centimeter, maximum is 22 centimeter, and the differential is tall. This is also not acceptable. What is the way out? Way out is you have to go for file foundation, no doubt. Unnecessarily, you are using more number of piles. As you use more number of piles, it is more costly. Now you see few more buildings from the same area. This is Commerce Bank. The construction duration is 94 to 97. This is constructed on the pile foundation. The settlement is 21 mm. It is perfectly all right. And then coming to the another tower that is called a main tower, constructed on CPRF. CPRF means combined pile raft foundation. Settlement is 2.5 centimeters. Perfectly all right. And then another one 3.2. that raft foundation is 11 centimeter. Maybe it is okay for this building, but height of this building is very less. The another one here also height is very less. This 10 centimeter is okay. But now you see very carefully, settlement of foundations, constructed on raft foundation is a little more, but the settlement of pile foundation is less. In between, you are going to have the settlement of combined pile raft foundation. Because of this combined pile raft foundation, you are going to reduce the number of files. That is how you are going to bring in the economy. Okay, this is what is a small picture about the CPRF. It is not a big picture. I have not shown the structure. This is how we are going to use the finite element modeling in order to evaluate the soil structure interaction effect. This is one building. I hope everybody knows this one. This building constructed on pile raft foundation. H.G. Polos was the foundation consultant for this. This has been covered very well in his recent book, Tall Building Foundation Design, available online. Please just see that one. This is more than 800 meters. See, just see the beauty of your finite element and the load test data. Actually, the finite element, this is what is your file configuration. Whatever your circular dots are there, these are the files. This is the finite element results. All these finite element analysis have been carried out, this TUD by Katzenbach. Now see this carefully what has happened. Actually, load test has been conducted by this consulting company. They could able to get the maximum load as 60 meganewtons. The corresponding maximum file movement was 2.2 centimeter. From the finite element, you could able to test the 60 meganewton, as well as you are able to evaluate little higher settlement. When you are using finite element, you have to evaluate higher settlement, and then you have to get lesser load. That is what is the funda behind using finite element, and then you have to verify it. Now finite element works perfectly all right. This has been covered very well in that book. Next, we'll move on. Another important thing with respect to the pile raft foundation is optimized geotechnical data acquisition. You have to evaluate. There is no substitute. In case of structural engineering, you have well-defined materials and quality assured materials will be there. In case of geotechnical engineering, first of all, soil is invisible. After all, we are drilling few boreholes here and there. That too, we are disturbing only 0.1% of the affected volume. With that, you are going to evaluate the parameters. Even in spite of ground investigation, soil is still uncertain. That's the reason one has to use engineering judgment in order to evaluate the soil parameters. There are many ways you can carry out investigations in situ. Especially the spicometer probe will going to use C5 gamma in the field at different depth. Laboratory, in case you want to do some advanced analysis. Small pile load test also can be performed using this, or else you can go for real pile load test in order to get the pile head load and pile head displacement. If at all you want to enhance the pile load test results, one has to go for Osterberg cells. Usually they will be used in 3. Usually one will be used exactly at the bottom. In case you have different layers, at the layer interface, one has to use and then test. Actually, Bombay people have tested more. We have done very few in Chennai. Okay, if at all someone wants to know a little more about pile raft foundation, this is the starting paper. Please go through this. It is available online, written by Polos and others. Now see, what is this pile raft foundation? Pile raft is a foundation which acts as a composite construction consisting of 3 foundation elements or load bearing elements. First one is the piles, second one is the raft, another one is the subsoil. In order to evaluate properly, one has to account for interaction between these foundation elements and the subsoil. Okay, this is what is a small picture about combined pile raft foundation. These are the different loadings, especially in case of industrial floor, we're going to have a UDL varying like this. The difference between conventional pile foundation and raft foundation is difference here. The moment raft is going to transfer certain loading, you will going to have the settlement dependent pressure like sigma xy of s. The total load coming on the pile raft is registered by the total resistance offered by the raft as well as the piles. Okay, here raft is going to offer the raft area multiplied by this stress, you are going to get the raft resistance and then summation of all the pile resistance. In the pile resistance, you are going to have the end bearing as well as the skin friction. You can just see. Already Mandolini and others have collected some data, experimental data. They could be able to evaluate the load shared by the raft. Usually it varies between 20 to 60%. For reliable design of pile raft foundation, one has to restrict the load transferred by the raft to the soil around 40%. Otherwise, settlement of your foundation will be too high. This I already shown earlier. The design philosophy as per a static analysis of pile raft foundation or statics design is concerned is number 3 curve. These are the different settlement curves based on different design philosophies. Here you can have a raft foundation. Usually what will happen in 3, you are going to design piles for the full utilization of capacity. That is what is one has to follow during construction of pile raft foundation. Okay, why first of all pile raft foundation? Question will arise. Nowadays, these are increasingly being recognized as an economical and effective foundation systems. Once you recognize as an economical and effective foundation systems for tall buildings, Somehow, most about tall buildings or high-rise buildings are supported on some form of pile foundation, which are subjected to combination of vertical, lateral, overturning moment. That is one thing. Another important thing, they are particularly effective form for foundations tall buildings. Not only in the previous case, the second reason, the raft is able to provide a reasonable measure of both stiffness and load resistance. This is very, very important. Here I am forcing the raft to transfer certain amount of load directly to the soil. By so doing, we are using that stiffness as part of the overall pile raft foundation system. Okay, the advantages are n number. Usually piles will be acting at the serviceability loads. If at all you want to utilize the capacity at ultimate loading, raft element will come into picture. Consequently, what are you going to do? It is possible to reduce the required number of piles when the raft provides this additional capacity. That is how we're going to bring the economy in the construction of pile raft foundation. Another important point, most of the times you're going to miss. As I mentioned earlier, sigma xy of S I have showed. Because of that, we are going to have extra lateral stress acting on the soil as well on the piles. Due to that, you are going to get a higher ultimate bearing capacity. This is usually not accounted in case of usual pile foundation, but this has to be. This is the added advantage. Here you can say it is a catch. Way back in 2001, Paulos, earlier it is an old paper. Nowadays you can use pile raft foundations everywhere except soft clays. In case your cohesion is less than 20 kPa, you are not supposed to use the pile raft. Please, you have to be very, very careful. Otherwise, you're going to face a lot of problems. Any type of soils, you can use a stiff clay, the dense, start with he has mentioned. But anyway, he modified his statement in the recent paper book, Tall Building Foundation Design. Okay, what is the catch here? I said a lot about the important catch here is understanding of soil structure interaction effect. It is indispensable for the proper design of pile raft foundations. One has to understand this very carefully. And then as usual, we have a design principles. Someone has to satisfy some issues. Okay, anyway, I'm going to go fast here. Construction is one of, as I mentioned earlier, no matter how complicated analysis technique, no matter how much knowledge you have, if you are not constructing properly, everything is literally useless. Basically, what you have to do, you have to have a geotechnical expert on the site, maybe appointed by the owner or supervising authority, and you have to have some protocols for the acceptance procedure. Let's assume you have built a 10-story out of 100-story building. The moment you mention 10-story, you will be knowing literally how much weight you are literally put on the soil. Based on the actual loading, you have to evaluate the settlement. Based on some monitoring exercise, already you have a prediction tool like a finite element. You compare. If the comparison acceptable, then you have to go ahead and continue the construction of the TPRF. With respect to this, we have an observational method. Anyway, I hope you may be knowing well aware. But it is not a substitute for round calculations. But in a way, it's a handy tool in case of geotechnical engineering. That another one is the monitoring. This is also very, very important. You have to decide upon the what type of instrument one has to use, what type of acceptance criteria one should use before execution of the PRF construction. With this, I'll move on to the analysis and design. I'll tell a little bit about. Now, you see this very carefully. This is exactly same figure. This is what I was telling about this. This is as usual overburden because of your gamma z. Because of the sigma xy, you are going to have in excess lateral stress on the pile as well as on the soil. Due to this, you will going to have the extra additional load or resistance coming from the overall pile raft system. That is the reason these are effective. Now you have to study a little bit about the interaction. In order to design pile raft foundation, one has to have the qualified understanding of different interactions. Please understand this word very carefully. Even if you are not going to take any point, this point you please listen very carefully. Designing pile raft foundation requires the qualified understanding of different interactions. Literally more than 6 interactions are possible. 2 interactions are not that important, but these 4 interactions are literally important. Okay, you can instrument properly, you can perform experiment, still you can evaluate the interaction. Otherwise, you have to have a sophisticated computational tool, you can evaluate all these interactions. And then finally, what is the total resistance coming? Total resistance is coming because of the raft. Please this very carefully. This total resistance is supposed to be much higher than the total load coming on your structure. Total load coming on the structure is supposed to be less than or equal to this total characteristic resistance. K stands for, nowadays in Europe, they are using limit state design. That is the reason this K word has been used. Total resistance is given by the pile resistance as well as the raft resistance. In case of pile resistance, you have 2 components. I am perfectly all right, please. Slide and explanation is perfectly matching.
Perfectly matching, sir.
Yes. Please see this very carefully. Pile resistance is having 2 components. One is end bearing, another one is the shaft resistance. This is for all the piles you have to add together. Then the shaft resistance is just integration over the bottom ground plan area of your raft. That means stress multiplied by area, which is again dependent on your settlement. This settlement is supposed to be well within the allowable settlement. The bearing power of CPRF is usually determined by the coefficient called alpha CPRF. This alpha CPRF is called as pile draft coefficient. This is defined by this total load taken by the pile divided by total load coming or total resistance offered by the pile draft foundation system. Based on this, you are going to decide whether my CPRF, combined pile draft foundation, going to behave like a raft foundation alone or else pile foundation alone or in between. In order to have a pile foundation CPRF effect, one has to restrict this number around 0.5. That is shown over here. This depends on the stress level as well as the settlement of the CPRF. This you can see clearly here. If it is 0, your CPRF is going to behave like a raft foundation. If it is 1, it is going to behave like a pile group. In that case, your raft is going to behave like a cap. You have to fix this number in between 0 and 1, usually around 0.5. That I will show you how to get that one next. Then finally, this is the take-home point. Design philosophy means this is stress strain curve or a load settlement. Basically, what you have to do, when you don't know how much one has to go along this line, usually 20% of this you have to go, then you will going to have the optimum foundation design. In case you have a doubt, you have to restrict at least at this kink. That means at this region, your pile and raft are elastic. The moment you cross, you follow on this line, your raft will be, your pile will be utilized. Your full utilization of pile capacity will be done on this. This is what is the design philosophy. This is also called load settlement curve. Okay. Sometimes you have a question, how to consider the pile Young's modulus. You are not supposed to use the Young's modulus of concrete alone. Depending on the percentage of steel used in your pile, this pi stands for the percentage of steel used. You can use this. It is the recent addition. Many people have done experiments. One can use this one. In order to understand the complex file structure interaction effects, one has to study like academic exercise. First, you talk about a circular raft with all these dimensions, single file raft model. You can instrument, you can perform experiment. Extensive experiments are needed in order to understand the interaction effects. Otherwise, you can use a finite element. You can make use of symmetry. Then after performing, now you see basically what will happen to the skin resistance. If you are at 10%, you will fully mobilize your skin resistance, and also to some extent you are mobilizing the end. If you have only 1% of your pile diameter, you are at this level. If you have 0.5%, you are at this. That means your everything will be under elastic as far as single file is concerned. And then coming to the single file raft model, see basically what will happen. The moment you have a raft, the tremendous skin friction is mobilized. This is the reason beyond why one has to go for pile raft foundation. But one has to understand how to evaluate these interaction effects thoroughly. Okay, now with this we'll move on to understand a little bit. So far we have done simple exercise. Now we see basically what will happen if I have a pile-file interaction. In case of closer spacing, where spacing is 3D, I have a center file, edge file, corner file. Similarly with all these specifications. And in the second case, what I have a larger space. When you have a larger spacing, there will be no group interaction effect. But you have to evaluate, you have to show through experiment or else through numerical simulation. Here I have performed, especially for load settlement behavior. With respect to your R total is exactly same. You can treat as 1 R total, 2 R total. What will happen? If you have a 2 R total, your settlement will be tremendous. Most of the times you will going to cross the allowable limits. That's the reason you would always consult. Whether you treat it as an individual pile foundation, spread putting, raft foundation, or else CPRF with only pile. In the CPRF, especially in finite element, you can force raft should not take the load. Like that you can do it. Or else as usual CPRF R total. This red line corresponds to that. This is what is shown in the design philosophy. Okay, with respect to now 3D spacing, you can treat it as a pile foundation alone or a combined CPRF. Now you see basically what will happen. What will happen to the load carrying capacity of the middle file, center file and edge file and single file. Load per single file is same. This total is a combination of RB and RS. This is applicable with respect to 3D. When you consider 6D spacing, now see this very carefully. What you can infer from this plot, there is no interaction effect. That is the reason the resistance versus settlement is not shown for single file. Okay, with this little understanding, let's move on to the understanding of few case studies. How people have used this file CPRF concept. This is one of the first applications in the world as well as in Germany. This particular building name is called Messetorus, which is situated in Frankfurt in Main, Germany. This was the first application in the world as well as in Germany. Construction duration is 1983 to 1985. These are the specification of the raft. The CPRF of the Messetorus consists of two separate rafts. One is north and another one is south. each with the 42 board files with a length of 20 meter and diameter of 0.9. Below each raft, the piles are arranged like this. 7 rows, 6 columns are arranged uniformly under each raft with the pile spacing of 3 to 3.5. This is very, very important. One should not stick to single pile spacing depending on the load coming. Whenever load is more, there you have to go for closer spacing. Whenever load is less, you have to go for larger pile spacing. The both rafts have dimensions. These are the dimensions of raft 17.5 into 24.5. Each raft is forced by an effective structural load of 200 megaton. It is a very high load. You can just see this is the isometric view of that particular tower. And this is what is your northern raft. These are the file configuration. And then R1 to R11. Actually, they have instrumented, they have performed the experiment, they have monitored during construction. R1 to R11 are raft pressure cells in order to know what is or how much is your sigma xy of S. And in order to know the variation of settlement along the depth, you have to use extensometer. In order to know the PROF generation, you have to use a piezometer. And then in order to know how much literally load is taken by the shaft as well as the bearing, and then how the load is getting varied along the length of the pile, they have instrumented these piles P6, P1, P2, P3, P4, P6. After the experimentation, this is what is your variation. Now you see the corner file is taking tremendous load here compared to the center file or even edge file. See, this is the edge file. This is the inner file. This is what is your edge. See, this is basically how it is going to vary pile load versus length of the file. Inner file is going to take a less load here, but the corner file is going to take a tremendous load. Accordingly, you can vary the length of the file. That is how you can bring in the economy in the foundation construction. Okay. Now I'm going to move on to the second case study. This is well documented in ISSMGE technical report. The report number is TC212. The name is Messertool, Frankfurt, Germany again. Basically, what they have done, initially they started with the concept of shallow foundation, that too using Raft. They could be able to get more than 40 centimeter settlement. First of all, it is not at all acceptable, and that to this 40 centimeter, the 75 to 80% they could be able to get within the top 20 meter. Again, it is very, very difficult. That means you are stressing top 20 meter below your foundation. This is what is your raft alone. This is what your raft alone. This is how the stress variation. This is how your Young's modulus was varying. How they have evaluated settlement. Simply you have to integrate your strain with the depth you are going to get the settlement. Finally, they ruled out the shallow foundation. They went ahead with the CPRF. This is what is our tower, and then height of the tower is 256 meter. This is what is the file raft foundation. Anyway, you can see in the next figure. This is what is the configuration of the file raft. The dimension is 58.8 by 58.8. Here they are used, depending on the load, they are used 3 rings. This is the center or inner ring. This is what is the middle ring, and this is what is your outer ring. Depending on ring, and then also they are used a different length. Please see this very carefully. This is more clear in the second slide. Now you see this is what is the configuration of the file raft. This is the thickness of the raft, and this is what is your one ring, another ring, another ring. But all the rings have different length. Totally, you have 64 files with a different length. Average length is 30 meter. Okay, with this, what they have done, they have instrumented as usual. Some are instrumented files, some are extensometer, and then they have 11 raft pressure cells. These are needed in order to know the raft pressure or stress transferred to this file, so that you can evaluate the load taken by the raft. Okay, based on file treatment analysis and based on the actual measurement, they could be able to draw this settlement contours. You can see the settlement variation. Maximum is 13 centimeter, minimum is 8. Anyway, you have a differential settlement. This building is capable of accommodating this differential settlement. This is how you can bring in the economy. I want to tell a little bit about. Now you see this very carefully what will happen. We have a central ring, longer piles. Then you have a middle pile ring. Then you have outer pile ring. See how the load is getting varied. Similarly, how the skin friction is getting varied. They could be able to evaluate through the actual measurements as well as the final treatment analysis. But the average load, in order to know the total cost of pile construction, one has to get the average load, and also you have to get the average pile length. Based on this, now we see basically what will happen. Now I have to evaluate the CPRF. What is the total load on the building? That means total load of the building is transferred to the pile raft is 1570 meganewton. Actually, it is a comma here. They could be able to achieve using CPRF with 64 piles. The load taken by the pile is 725. Difference is taken by the raft. The raft load divided by the raft area is 250 kN per meter square. It is well within. Using this, you can follow this formula, and then you're going to get. As I mentioned earlier, CPRF has to be around 0.5 so that you can reduce the settlement well within the allowable limit you will going to get. Then what about the environmental consideration? If you do this exercise, what are you going to gain with respect to the materials and the environment? Here is the slide. Comparison of cost for the piles. present building has been achieved using CPRF of 64 piles where average length is 30 meter. Then what about the cost of pile production? 64 piles of 30 meter at 780 US dollar. Actually, it is at 15 years back we have got these calculations. 1.5 million US dollar. We could able to construct this building foundation with this cost with the CPRF. Instead of this, you could have gone for pile foundation. You could have required 316 piles with average pile length 30. In this case, what is the cost of pile production? 360 multiplied by 30 multiplied by 780, 7.4. Difference is savings in cost of pile production. Please see the number. This number is very high. Pile sorting, basically what you have done? You have literally reduced the CO2 reduction 2,500 tons. That is how you can bring in the economy as well as you can reduce the impact on the environment. Okay. And then another important thing, what is the take home point here? Basically what you have done, you have reduced the settlement by 50%. Otherwise what would have happened? You could have gone for Raft foundation, you could have increased the settlement by 50. Then what is the savings? You could have gone for file foundations, you could have invested 60% more than the usual cost of your CPRF. That is how you have to bring in the economy and even safety. Okay, with this I will stop. Basically I have a few more case studies I will simply run through. This is what the another bank during construction just before finishing. This is how, in this case, they could able to save 9.2 million US dollar. CO2 reduction is 3,300. Similarly, few more examples are there. You can just please go through this. These are all available in that book and then published paper. Is the another one city tower open back in Germany. They use finite element analysis. Okay. Another one is especially business-based district. Many times what will happen? Our geotechnical engineers are always giving lesser value for 70. Exactly this happened in Dubai. Based on actual pile load test and finite element analysis, they could be able to. Sangeeta, something. Hello. Hello, I am audible.
Yes, sir, you are audible.
Yes, please. Something has come in between. Oh.
Nothing has come between. It's audible.
Now it's fine, please.
Yeah, it's fine,
Okay,
sir.
you please reply basically. Clear. I'm telling all the audience. Someone wants to know more about File Raft Foundation. This case study is ultimate. Please see. Business-based districts, Dubai. Actually, they committed a blunder. Geotechnical guys, especially report, they given 78 meganewton. Literally, after based on pile load test, they could able to back calculate Young's modulus at this number. Because of this, they could able to reduce the pile length by more than 20 meters. Okay, that's what finally they could use only 17 meter or 18 meter pile length. These are your mechanics of material calculations. One can use these things also in order to evaluate the effectiveness. Okay, they use again your flaxes here. It could be able to, instead of using 40 meter, initially they were suggested 40 meter. Finally, they end up using only 18 meter. They could be able to achieve the construction. And then what are the recommendations? These are the few recommendations. One can have n number of recommendations. Piles have to be set directly under the load of the superstructure. That to at the center of the pile group should be under the center of the load. A few long piles are better than many short piles. Many a times what will happen during board cast in situ, you cannot change the diameter. At the most, you can change the pile length. The length of the pile has to be adapted to the loads. At the edge and the corners of the raft, shorter piles, and in the inner part of the raft piles, depending on your configuration of your structure, you can decide this. The optimum CPRF coefficient, this is very, very important. You have to evaluate. You are not supposed to cross more than around 0.4 to 0.5 is perfectly all right for Indian conditions. Okay, a few more recommendations you can think of based on whatever presentation you have listened. Right now, the highest high-rise building is Kingdom Tower. Construction is going on. That too in Jeddah. Please see this figure very carefully. This is what is your Darmstadt. He is the captain back. This is the Jeddah where you have Burj Khalifa is here. Jeddah Kingdom Tower. And then he is the captain back. He analyzed this. This is what is the tower. Anyway, it is isometric view, not yet ready. It is more than 1,007 meter. And this is what is your foundation configuration. Please see this very carefully. You don't have to go for prismatic shapes. You can play with. Now the softwares are handy. You can play with. Then finally they could able to test. They have 3 layers. Is the upper layer, mid layer, and then they could able to use these Osterberg cells. Then see basically how much they could able to get. More than 660 km square. We are thinking of how much one should use skin friction in case of Indian conditions. One can learn from this. It is also available in the case study format. Then they use a finite element, okay, and they have their own code. And then see here what happened. Finite element results, here is a load test results. The perfect matching between the load test result as well as finite element for the upper pile segment. This is what, that is the middle pile segment you can have. Okay, that's it. I have planned some future directions. You have to optimize. You have to bring in the optimization. You don't have to go for uniform length. Wherever the load is more, there only you have to go for longer length file. Wherever load is less, there you have to curtail the length of the file. But you have to show this through proper analysis. Qualified understanding is a must. Otherwise, no one will accept. The another one is elastoplastic analysis. Nowadays, what are you doing? Basically, you have to reduce the internal stresses and the bending moments in the raft. Everything depends on the stiffness of your raft. If you are not evaluating stiffness of your raft properly, you are not supposed to transfer load unnecessarily too much to the soil directly. This is one thing. There are many more, and these are the some summary, please. This is the last slide, please. Design of file drafts requires a detailed and adequate site investigation program to collect all relevant data of the subsoil and ground conditions. An economic and safe design of PRF is only possible if soil structure interaction is considered using adequate and reliable calculation methods. Here one has to have a qualified understanding. The design of a raft has to be controlled and proven by an independent geotechnical expert concerning the relevant assumptions and calculation model and the results calculated by the designer. Application of the observation method is an important aspect for the successful design and construction of file drafts and is recommended in every case. Especially in geotechnical engineering, you have to use this observation method, but don't think as an alternative for wrong calculations. No doubt it is a handy tool during execution. One has to use this one. With this, I am going to stop. There are many issues to be solved in future. You can think over, hopefully who are working in this particular field, they may be aware. Okay, one especially quality assurance and control is very, very important apart from sophisticated analysis. A few concluding remarks anyway are not added. Already many people have attempted and then they have compared the performance using different softwares, even Plaque 2D, 3D are used, Plaxis 2D are used, ANSYS is used, even nowadays, especially Australians are using Abacus software. They are giving comparable results. One can depend on most of these softwares. This is the statement for young students. Don't expect to become an expert overnight. Intelligent effort is needed. And this is also very, very important. Knowledge, understanding, and will to implement are the prerequisites for effective implementation of any tool. As a professional engineer, as a teacher, we have to have knowledge about the system. Knowledge is not sufficient. You have to have proper understanding. Once you have understanding, will to do and will to implement are the mantras for successful implementation of any tool. With this, I will conclude my talk. Thank you one and all for patient hearing.
Thank you so much, sir. That was a very enthusiastic, energetic.
Okay. But there was no problem in between, no?
No problem, sir. It went on absolutely. It was marvelous.
Okay, when you have done the mock presentation, that time you had a few problems. That is the reason I was worried. In between, I was asking.
No, it was.
Whether I am synchronous with my slide.
Flow, sir.
If I am presenting one slide and the explanation is something else, otherwise people would have fired. Anyway, thank you so much, please.
Perfectly synchronized. Thank you so much, sir. You can remain
questions
on
are there.
Yeah.
If at all any questions,
we will take the questions later. We will have the valedictory section.
Yes, please. Yes, please.
Thank you. Panelists have also joined. Yeah.
Yes, please. Yes, please.
We will
thank
take
you
the
so
question
much.
after the valedictory section, sir. So
yes, please. Yes, please. Thank you. Thank you.
So we have the panelist, Dr. Prasanna, Engineer Prakash, and those who are there. So before going on to further this thing, let me invite Engineer S. Prakash for the opening remarks about the conference. Sir, over to you. Engineer Prakash, you are able to hear me? I think your mic is...
Anil sir, can you be the presenter so that the is gone?
Okay, then let me get over to Dr. S.K. Prasad for the summarizing part. S.K. Prasad, let me introduce him. S.K. Prasad?
Yeah.
You are there.
Audible?
Sir, let me just give a brief introduction of Dr. S.K. Prasad. He retired as Professor in Civil Engineering at Sri Jayachamrendra College of Engineering, Mysuru. He is having over 35 years of teaching and research experience. He obtained his bachelor's degree in civil engineering from the University of Mysore, securing first rank in 1982, master's degree in geotechnical engineering from IIT in 1985, and doctoral degree from University of Tokyo in Japan He was a visiting assistant professor at Asian Institute of Technology, Thailand, and he has published over 160 technical papers in national and international journals and conferences. And he has guided a number of masters and doctoral theses. Let me invite Dr. S.K. Prasad for summarizing the proceedings of the conference, sir.
Thank you, Engineer Anil Kumar Pillai. Can you help me to share my PPT?
It's not with just a minute.
To whom, sir, I have to provide? Anyway, I'll have to thank everybody for making this Ragi 2020 very successful. So if I have to really thank, one group, it is the speakers. My, real namaskaras to all the speakers who made it really happen.
Your video is not visible, sir. Prasad, sir. Not able to see you.
Okay, is it visible now?
I think you unmuted. Now we are visible.
Okay, and then what about sharing? I would like to share the.
Yeah, I think there is some problem in that. Share content, there is some problem, I believe.
Mr. Karthikeyan, can you please?
Yeah. Now it's okay. Now it's okay. Okay. Very good afternoon, everybody. So we have come to the end of Ragi 2020. So Ragi stands for Recent Advances in Geotechnics for Infrastructure. Ragi is also a staple food in South India, especially in Karnataka. So we want this Ragi also to be the staple food for the civil engineers. Generally, if you ask a common civil engineer to name a few construction materials, or maybe a student, usual answers will be cement, concrete, steel. But very few will say that soil is also a common construction material. But if you just see, an earthen dam or maybe an embankment, entire material used here is soil. So I have made the statement here that soil is the most common, most used, and least expensive construction material. I hope all of you agree with me. It is naturally available, therefore you don't have to spend anything on it. But today, you may have to transport it from one place to another to get the good quality soil, or maybe you may have to modify its properties. That's why I said least expensive. Further, you build any structure on the ground. Therefore, soil is most important to civil engineers. But it is a very complex construction material. And generally, when I say complex construction material, it is difficult to understand. I always admire the message given by Professor Madhav. He says that practicing geotechnical engineering is a combination of both art and science. So what does he mean? So if you have a geotechnical engineering problem, then if two geotechnical engineers are giving solutions, there is every possibility that they may be giving two different solutions, unlike in structural engineering. So indicating that they are using their artistic knowledge in addition to the scientific approach. Well, I said that soil is a very complex construction material. You can list a number of properties which make soil a complex construction material. What do I mean by complex? Difficult to understand. If I give you steel rod and ask you to find its tensile capacity, maybe you will try to understand what is its dimension and you'll be able to assess. Maybe with concrete also it is possible. With soil, it is very, very difficult because of many complex characteristics. I just want to draw your attention to a few interesting characteristics of soil. Soil is colorful. All of you agree with me. Soil is sensitive. Some soils, like hypersensitive clay, they have some good strength intact in their place. But the moment you take them out and bring it to the laboratory, probably the strength reduces even sometimes to zero. Soil also has memory. you can show that through E-log P curve in consolidation test. Therefore, it knows exactly what load, what pressure it was subjected to before. If the present pressure is more, it behaves in some way. If it is less, the behavior is different. It changes its properties with time. If I take water content, during summer, water content will be less, maybe even zero in some places. And during rainy season, it will be more. So if you just see these characters and compare them with human beings, they all match with those of human beings. I hope all of you agree with me that human beings are colorful, sensitive. Hopefully we possess memory. We keep changing our properties with time. We make one statement in the morning, the second statement in the afternoon can be totally contradicting. So what I want to draw your attention to is that soil is comparable to human beings, or soil is some material which has got life, unlike steel, unlike concrete. Therefore, you should treat soil with respect. So soil, I always say, is an intelligent material, smart material. So if you treat it well, if you respect it, it behaves according to your requirements. Otherwise, it misbehaves, shows in the form of failures. So I just want to mention, take these things in mind and mention that we civil engineers will have to give importance to soil. We should not neglect soil. Keeping that in mind, we set our objectives for RAGI 2020. So basically, to enhance the knowledge of the civil engineers in advancements in geotechnical engineering, which is happening continuously. And then to bring together stalwarts in the area of geotechnical engineering under one platform. I'm really proud and happy stalwarts, 4 speakers have agreed and come together, and we are privileged. And then to strengthen the industry institute interaction, bringing together 2 of the finest engineering colleges in Mysore, SJCE and NIE, along with 2 very important professional bodies, Association of Consulting Civil Engineers and Indian Geotechnical Society. And then, industry, Ramco Cement, really, you made, RAGI 2020 wonderful, and L&T also have joined us. So through this webinar, we brought them together, and whatever we say in, academics, industry institute interaction, that is perfectly done with this. And our intentions were to make that, this knowledge sharing goes to more than 1,000 people. I feel so admired and happy that it is not just 1,000, it is 6 times more. On an average, every day we have had about 6,000 professionals from across the country listening to the wonderful speakers. So just a little history about RAGI. We started in 2014. The objective was to alternatively conduct at SJCE and NIE every year, and to cater to the needs of engineers from Mysore. We had very good crowd in all these RAGIs, about 150 to 180 engineers in each of them. So in 2018, we decided that we make it biennial. So that means, every 2 years, because we thought of conducting, ACC thought of conducting, alternatively, RAGI recent advances in civil engineering in the other year. So we were scheduled to have RAGI this year at NIE on 21st March. Unfortunately, the recent global pandemic just shattered our dreams. So we were simply thinking that, we may not be able to start RAGI in the near future. But our chairman, Engineer Prakash, and the secretary, Engineer Ram Prasad, had different ideas. They just asked us whether we can think of something alternative. So we formed a core team of 5 of us. All of us are here, and we decided that we go for a webinar. So then the question was, how do we reach out to as many people as possible? Fortunately, Ramco came to our rescue, and we have had wonderful seminar for the last 4 days. I just would like to brief what has happened during these 4 days. Professor Madhav gave his talk on some challenging geotechnical solutions on Thursday, the 14th May. In fact, Professor Madhav is my guru. I did my MTech way back in 1983 and 84 under his guidance at IIT Kanpur. Sir, you were as flamboyant as you were during those days. I really felt so happy to listening to you. He spoke on the coastal erosion in Gulf of Cambay of Gujarat coast, high reinforced soil wall to widen the Ghat road, and then the construction of building on very soft ground in the coast. So all these using the recent geotextile and reinforced earth. He also talked about Pakyong Airport, Sikkim, where one of his students was involved with the construction of very high reinforced wall, earth wall. So his remarks are very important. In some cases, he says, ground is much stronger and stiffer than what is indicated by soil report. So we'll have to be very careful, and we have to identify in which cases they are stronger and stiffer, because we are not supposed to make any mistake. And then, he says the challenges in geotechnical engineering come in very different forms because of the uncertainties and variabilities in ground conditions. And he also stresses that monitoring the behavior of structures, especially the geotechnical structures, is very, very important, which is not happening to the desired level. Then the next day, on the Friday, 15th May, we had a presentation by engineer Mohan Prasad. He spoke on some common misconceptions about geotechnical investigation. Sir, you were really, reaching out to the structural engineers, the basic fundamentals, the importance of geotechnical investigation, and then how the investigation should bring in structural engineers and geotechnical engineers together. And you also stressed that you'll have to look at the site globally, not looking at in isolation. And you stress that geotechnical engineer should not stop the looking at the site up to investigation alone. Even after that, he will have to go and see whether whatever report he has given is realistic or not. So in general, you said that geotechnical investigation and foundation design should be made considering collateral effects of excavation, construction of foundation, and neighboring structures. Yesterday, on Saturday, 16th May, we had a wonderful presentation by engineer Anirudhan. His title of presentation was Significance of Case Studies in Geotechnical Engineering. He discussed various case studies, very challenging ones, which he undertook. And so they encompass geotechnical investigation of foundations, ground improvement technique, and then, the storage tank foundation, performance of soft deposits, and gabion fascia using laterite blocks. He emphasized that case studies are necessary. He also emphasized that one can learn better from understanding the failures and understanding the success. He said that better documentation is essential, just the same way as Professor Madhav. He is also a student of Professor Madhav. The last presentation today by our dynamic friend, Professor DODAGOUDAR, he connected materials, environment, with piled raft foundation. So he spoke on the choice of material to reduce the impact on environment. He highlighted the practical applicability of piled raft foundation, and from finite element analysis, piled raft foundations are identified as economical, effective foundation systems for tall buildings. And he said that raft provides additional stiffness and carries extra load in foundation system. So wonderfully, he connected materials, environment, and piled raft foundation. So quickly, I would like to go through the salient features of RAGI 2020. As I told, number of participants was amazing. So on day 1, day 2, day 3, you can see those connected through WebEx and those connected through Facebook. And day 4 also, I'm sure we would have had similar number. I don't have the data right now with me, and almost around 6,000 or 6,000 plus participants connected. In fact, afterwards also in Facebook, there were a lot of hits, hundreds and maybe even a couple of thousand hits on each of these days proceedings, which makes us feel marvelous, makes us feel very, very satisfied. And then, we had extremely lucid and highly informative presentations from all the speakers. Even the question answer sessions were also pretty interactive. Feedback suggests that participants are very happy. In fact, even today we got the feedback about the DODAGOUDAR's presentation, and participants were very, very happy. I need to thank Ramco for agreeing to whatever we asked for, and e-certificates are being provided to each of the participants for every day separately. And the speakers were kind enough to provide their materials for preparing the proceedings. We prepared a lovely proceeding, and that is being put on the ACCE website, www.acce.in. All of you can take those materials and make use of them. Shortly, the videos of the lectures also will be made available to the participants, and you can download perhaps from the same website. But presently, you can view that on the Facebook of Ramco Cements Limited. This webinar was more successful than our conventional one in reaching out to large number of delegates. It has definitely eliminated the tedium of travel. It has cut the cost and allowed the participants to listen to the lectures leisurely at their places of comfort. There are a number of takeaways from this online webinar, RAGI 2020, that too during this grave situation of COVID-19 global pandemic. So thanking all those responsible for success of RAGI 2020 will be made by my good friend, Engineer MS Ramprasad, who is the Honorary Secretary of ACCEI Mysore Center. With this, I end my presentation. Let us look forward to an even more successful RAGI 2022. Thank you very much.
Thank you, Dr. Prasad, for that wonderful summary. And in fact, we at Ramco Cements are also very happy to be a part of the first virtual RAGI 2020. And let me thank you so much, sir, for your good summary. And you have summarized it very well. Let me invite Engineer Raviraj, sir, for his remarks on the conference.
Good afternoon. I appreciate the efforts of Dr. S.K. Prasad, who took the lead role along with Dr. H.S. Prasanna to make RAGI 2020 a reality. Initially, we had a target of reaching out to an audience of about 1,500, but we are overwhelmed by your support and response. We thank each and every one of you to have spared your precious time on all these 4 days and being a part of RAGI 2020. We look forward to your continued support for RAGI 2022. I appreciate the efforts put by the office bearers of ACCEI Mysore Center, Indian Geotechnical Society, Bangalore chapter, the Sri Jayachamrajendra College of Engineering, the National Institute of Engineering, Ramco Cements, and Larsen & Toubro to make RAGI 2020 very successful. RAGI started in 2014, and this is the 6th in the series. I'm happy to have been associated in all RAGI programs. A total of 27 geotechnical experts have shared their knowledge in RAGI platform. I sincerely thank all the speakers of RAGI for making it very popular and successful. RAGI has transformed itself from a local event to a national event. Hopefully, we may see a couple of speakers from other countries in RAGI 2022. Today is a very special day for ACCEI Mysore Center, since this center was started on this very day, 17th May in 2001. The valediction of RAGI 2020 makes it a more special day to all of us. Thank you.
Thank you, Raviraj sir, and congratulations. This being the special day, especially for Association of Consulting Civil Engineers at Mysore Center. Nice that everything coincided. When the auspicious days come, all auspicious events coincide. So that is something that we could learn from this. Let me just invite Dr. H.S. Prasanna for his remarks. Over to you, sir.
Good afternoon, one and all. As you know, the soil testing investigation from primitive level of testing few centuries ago to the latest technique in the 21st century. As you believe, seeing is believing in civil engineering. In ROGI 2020, we have seen very illustrious lectures by Professor Madhav, Engineer Mohan Prasad, Engineer Anirudhan, and Professor DODAGOUDAR made this ROGI a very effective mechanism for learning platform. As most of us know, it is to achieve the maximum efficiency in the bearing capacity through soil structure interactions, a viable alternative to sustainable development. As we have seen in rammed earth construction, large underground caves in Europe, and even clay as a material in the history. Everything says we have to respect the laws of nature. I unquote one famous quote in English: graduation is a milestone where idiots stop learning. But our speakers of ROGI 2020 have motivated all of us to learn throughout our life. I sincerely thank all the speakers and all co-sponsors for making ROGI 2020 a very grand success. Thank you, one and all.
Before the vote of thanks by Engineer Ram Prasad, let me also give an opportunity to the speakers for sharing their final comments. Let me invite Professor Madhav sir for sharing your thoughts. The conference.
Can you hear me now?
Yes, sir.
Okay. I would join every one of you saying that it has been a memorable, unique event in the history of our Indian context to reach out so many people all over the country. And I believe a few people from abroad also have joined it because they called me and said it's great. So I would like you to take a role model and say, let's propagate this. And since you all learned so much about geotechnical engineering, all I would request my structural engineers is it's a joint effort in most of the projects. The input from geotechnical engineering can make a big difference to you. So try to involve them from beginning, during the design, construction, and help in monitoring. Once you get the confidence in terms of the performance, you can improve your design in future. All I can say is that everybody says everything. There's nothing much to add for me. It has been my own unique experience of trying to reach or having reach so many people. I'd like to thank all of you, SSCE, Mysore, Bangalore, Ramco, LNT, and the two colleges, JC College and NIE. And I'd like to thank Prasad, who was responsible for me to be part of this. Thank you very much and all the best to you.
Thank you so much, sir. It was wonderful listening to you, and there were a number of views on our FB page also on your presentation. So it was taken very nicely, and I'm sure that most of them would have got the insights on geotechnical engineering. Now over to the next speaker, Engineer Mohan Prasad, to share his views on the conference, sir. Hello. So Engineer Mohan Prasad.
Am I audible?
Yes, sir. You are audible. Yeah, please.
Good afternoon. First, I want to thank and congratulate the organizers and sponsors for this wonderful platform, national platform. A lot of thoughts were shared. I would like to share some of my thoughts, rather concerns, that keeps coming back to me again and again, especially regarding the engineering colleges. Almost all of us have been on both sides of the divide, being teachers and being consultants. And Professor S.K. Prasad talked about industry engineering interaction. Perhaps it may not be at the desired level. It could be deepened and extended and this seminar is a wonderful opportunity towards that direction. And regarding the other things like internships, project works, and seminars, they offer possibility for a robust and meaningful interaction between students and practitioners, so that the gaps between the curriculum and practice can be plugged as much as possible. But somehow we see that this is subverted to becoming mundane, routine, mechanical exercises, compromising on the very principles on which it was framed. And second thing I want to tell about this engineering colleges, which is nursery for growing our geotechnical engineers, is the faculty are not sufficiently encouraged, supported by the powers that be to indulge in consultancy and initiate the sub-staff and the students and also involve them. And the next thing I want to tell as my experience in teaching is, so I think we can pick up a few points from Montessori schools, like making our teaching more activity based. Anyway, one can chew on that. And the second thing I want to talk about is the fact that there is a lot of distortions have crept into our practice. We all know that. And like engineers, thinking like engineers that we are, so we have to strike the problem at the very root level for effective and lasting solutions. To my mind, one thing that comes readily is poor instrumentation. I can recall my experience when there was IGC in Tata Indian Institute of Science. After that, there was a meeting of IGC. I walked into it along with Professor Vijendra, so thinking what to do with funds to do, and some people were even suggesting why not invest in banks and like that. Anyway, I was thinking loudly, a instrumentation project can be commissioned for boring equipment that comes in between the manual boring, and the rotary water boring rig we normally employ, because that is source of many of the distortions we are facing today. The kind of we extract, and the veracity of standard penetration tests we do and all is least inspiring, to say the least. And something could be done about that. I also remember one instance where I went to Professor Babu to ask if there are any instruments to determine the thermal resistivity of the soil, which is important while designing the installations surroundings for the underground cables. So instrumentation is one. I think something can be done about that. I also think the standardization and certification is something IGS can look at. Anyway, I thank this opportunity, and like everybody said, it's a great success, and I thank all once again.
Thank you, Engineer Mohan Prasad. In fact, there has been a number of views on your talks, and you had very beautifully brought out the analogy of clay and sand foundation with the human behavior, which I think most of them would have appreciated. And you had brought in different perspectives to geotechnical engineers. So thank you, sir, for that. And let me bring in the third speaker who spoke yesterday, Engineer Aniruddhan, sir, on the significance of case studies in geotechnical engineering. Over to you, sir, for your thoughts on the conference and your concluding remarks.
Yeah, thank you, Anil. Yeah. A big thumbs up for the Ragi team to have successfully conducted a workshop virtually reaching very large audience. In spite of the huge success by reaching large audience, I feel that there is nothing like meeting each other face to face, because socializing is akin to all the living beings, not only for the human beings. So let us have a chance to meet up in the near future, and wish all success for the coming Ragi events and other events which Ramco and the team members will take up in future. That's all from my end. Congratulations again to all the members. Thank you very much.
Thank you, Aniruddhan, sir, for that sweet and short conclusion. And your talk was very interesting, and it has been taken by a number of viewers on both FB as well as Webex platform. Let me give the next opportunity to the speaker of today for his concluding remarks, Dr. G.R. DODAGOUDAR, for his concluding remarks on the conference as well as his final thoughts before we go to the question answer session after the vote of thanks. Over to you, sir. Not able to hear.
Hello.
Yeah, now here. Yes, sir. Please.
I have only two things to say here. First of all, I want to thank organizers and then sponsors. The second one, next time, if at all you want to have any sessions, at least you please have one session on uncertainty modeling and analysis in geotechnical engineering. Already Professor Madhav sir has already mentioned in his talk. Please think about that, because of all uncertainties only we are going to face a lot of problems during execution of geotechnical engineering projects. That's all. I have only this much to say. Thank you.
Thank you so much, sir. Before going on to the vote of thanks, let me see if Engineer S. Prakash would like to add some views if he's on the online. Engineer Prakash. Sir, are you there? Okay, then vote of thanks by Engineer Ram Prasad. He's also not there. Ram Prasad, sir?
Yes, sir. Am I audible,
please.
sir?
Yes, sir. You are audible.
Yes, sir. Good afternoon, one and all. On behalf of ACCI Mysore, we would like to thank all the participants of RAGI 2020 webinar. In the beginning, we were very skeptical about the success of this webinar, as this was our first venture online. However, with a total login of over 25,000 viewers since 4 days, we are overwhelmed by your response. Thank you all. We thank all the resource persons who took time in spite of the busy schedule and for enlightening us about various topics of geotechnics. Very senior Professor M.R. Madhav gave a momentous push with his presentation on some challenging geotechnical solutions on 14th of May. It was very well appreciated by one and all. Thank you, sir. Engineer Mohan Prasad from Geometrics, Bangalore, gave an insight into some common misconceptions about geotechnical investigations on 15th of May. Thanks, sir, for the wonderful presentation. Engineer I.V. Aniruddhan from Geotechnical Solutions, Chennai, stressed on the significance of case study in geotechnical engineering yesterday. Thank you, sir, for the excellent presentation. We thank Dr. G.R. DODAGOUDAR, professor from IIT Madras, for sharing his knowledge and enlightening us about the material and the pile foundation. Thank you, sir. We would like to thank all the organizations who supported us. We thank the principal, Dr. T.N. Nagabhushan, Dr. K. Prakash, HOD Civil Engineering, management and staff of Sri Jaichamarajendra College of Engineering, Mysore. We thank Principal Dr. Mohini Nagapadma, HOD Civil Dr. K.C. Manjunath, management and staff of National Institute of Engineering, Mysore. We thank Professor G.L. Shivkumar Babu, President, Indian Geotechnical Society, Dr. Parthasarathi, Chairman, Bangalore Chapter, and all the members of Indian Geotechnical Society for the guidance and support. We thank Dr. M.U. Ashwath, President of ACCI, and all the members of ACCI from different centers for the encouragement and support. We would like to thank L&T Corporate Training and Engineering Academy, Mysore, for joining hand with us. As usual, Ramcos Cement are very supportive to our activities, be it Engineers Day or Industrial Outreach Program for students. This time, they have joined hands for RAGI 2020 also, and they have been the prime driving force for the success of this webinar. We thank the management and staff of Ramcos Cement Limited. Engineer Anil Kumar Pillai, General Manager, Technical Services, Ramco Cement, has been an excellent moderator throughout this webinar. Thank you, sir. We would like to thank Engineers Suraj Kumar, Engineer R. Karthikeyan, the host, and all the IT professionals behind this show. They have done an excellent job Thank you all. We would like to acknowledge the support of Engineer Shashank Sharma, Bengaluru, Engineer Santosh, Mr. Rajkumar, and Team Ramco from Mysore. Thank you all. Dr. Raviraj, our own member and professor of SJCE, was instrumental in bringing out the proceedings of RAGI. Thank you, sir. We thank Dr. H.S. Prasanna and Dr. H.K. Prasad, Chairman and Honorary Secretary of RAGI 2020, who have put in a lot of effort in making this event a grand success. Many brains and hands have worked to make this event a memorable one. We thank all of them. We thank all the members of ACCI Mysore Center for the support. Once again, I thank you all. We shall look forward for a grand RAGI 2022 with all your support and encouragement. Thank you all.
Thank you, Ram Prasad sir, for that Thanksgiving this thing, and it was really a very good concluding session. As you, all the speakers were saying, the first virtual conference, went off very well, and only thing that was missing was the face-to-face interaction, which I am sure that we would be having. Let's pray that we would be having in the near future. The face-to-face interaction is something which cannot be replaced, but then we have fulfilled our objective of knowledge dissemination even through this media as well. So that was a good this thing. Thanks to all the organizing institutions, Association of Consulting Civil Engineers, Indian Geotechnical Society, L&T, NIE, Mysore, SJCE for that wonderful program. Now, before we wind up, let me just take few questions for today's speaker, because there are some questions which have come, so let us not neglect that. So before we go on, there is one question which has been spoken about, the lateral load coming onto the pile raft foundation, DODAGOUDAR sir. That is, yeah, on the pile raft foundation, what about the lateral loads during an earthquake? Is there a rigid connection between the pile as well as the raft? That is the question that is being asked.
You are, anyway, you have to have a rigid connection. Yeah, you can handle that lateral. See, if you design pile raft foundations for axial loading, if it is maybe up to 20-story building, if you are designed properly, executed construction properly, up to 20% of the axial load can be treated as lateral load. Your speculated earthquake loading is well within the 20% of the axial load, perfectly all right. If it is more than that, you have to perform explicitly the earthquake analysis.
The last question is, the last question of the day is how to calculate cohesion at soil raft interaction.
Cohesion?
Cohesion at soil raft interaction. Is there any?
Soil raft? No. Before construction of the pile raft foundation, anyway, you will going to do soil exploration. Okay. Based on that, you will going to get the variation of cohesion. Wherever the depth of foundation, that means bottom of your raft will be knowing at what depth you are going to have it. Usually that value only will be there. Depending on the water table fluctuation, that value may vary. That anyway you have to account for.
And is Duncan-Chung hyperbolic model can be used for cohesive soil?
Yes, please, definitely, because that are not touched upon constitutive modeling. Nowadays, people are using even much beyond that. Yes, that model is already there in Plaxis.
Which type of which type of interface element mostly suit for soil raft interaction?
Okay, you can use zero interface element, or you can have minimum thickness. Few mm thickness interface element one can use.
Thank you so much, sir, for clarifying the queries of the audience. And if there are any more questions, I will just send an email to you so that you can be clarified.
Yes, no problem, please.
And yeah, it was really a combination of all the talks. I think has brought the entire aspect of geotechnical engineering to all our, wherever we are there at our convenience. You had the privilege of listening to that. It was really a massive effort by all the institutions which came together, because coming together is something very difficult. And here we have made it possible that by coming together, we can have a seminar which has a lot of consequences in terms of knowledge dissemination, and as well as bringing practice and theory together to clarify the concepts. And I feel that we all of us have been able to achieve the objectives and given a kind of push to the audience to explore further on the aspects of geotechnical engineering. And in the days to come, I'm sure that a lot of queries, lot of questions, lot of interest would be generated in this field. So with those few words, let me once again thank all the panelists, all the speakers, all the institutions for making it possible Ragi 2020 would be memorable in our lives. And I'm sure that all of you would have got the thing. Thank you, all of you, for having joined. In spite of pandemic, we have been able to involve every one of them in the construction sector. Most of them have come, and I'm sure the videos would also be seen much more. With those few words, let me again thank and all the best. Thank you so much, sir.
Thank you.
Thank you, Anil.